Next problem is problem number 7. Prove 3 raised to power 2n plus 2 minus 8n minus 9 is divisible by 8 for all n belong to n. So here we have to prove this result is divisible by 8. The solution is that let Pn is 3 raised to power 2n plus 2 minus 8n minus 9 is divisible by 8. That is our statement. So step 1, that is we have to prove the result for n is equal to 1. For n is equal to 1, P of 1 is 3 raised to power 2 plus 2 by substituting n is equal to 1 minus 8 into 1 is 8 minus 9. Therefore, we get 3 raised to power 4 minus 17. 3 raised to power 4 means 3 into 3 into 3 into 3. That is 81 minus 17. That is 64. And if we factorize 64, we get 8 into 8. That is P of 1 is 2. Because 8 into 8 is divisible by 8. So P of 1 is 2. Now we will proceed further, that is step 2. Let us assume that result is true for n is equal to k. That is P of k is 2. That means P of k, that is 3 raised to power 2k plus 2 minus 8k minus 9 is divisible by 8. As 3 raised to power 2k plus 2 minus 8k minus 9 is divisible by 8, that means 3 raised to power 2k plus 2 minus 8k minus 9 is a multiple of 8. Say 8m, where m is any natural number. So it is a multiple of 8 by the definition of divisibility. That is due the definition of divisibility. Now we will proceed further, that is step 3. Here we have to prove the result for n is equal to k plus 1. That is, we have to prove P of k plus 1, that is 3 raised to power 2 into k plus 1 plus 2 minus a into k plus 1 minus 9 is divisible by 8. That means if we prove this statement is equal to 8 times some number, or we can say that is a multiple of 8, then we say that P of k plus 1 is 2. So we take that element, that is, we will solve this statement, that is 3 raised to power 2k plus 2 plus 2 minus 8 times k plus 1 minus 9 is equal to 3 raised to power 2k plus 4 minus 8k minus 8 minus 9. Or we can write 2k plus 2 into plus 2 again minus 8k minus 17. We can write it as 3 raised to power 2k plus 2 into 3 square minus 8k minus 17. Because we know that x raised to power a into x raised to power b is equal to x raised to power a plus b. So here we can write these terms as by using this principle. So from step 2, we have 3 raised to power 2k plus 2 minus 8k minus 9 is equal to 8m. From here, we will get 3 raised to power 2k plus 2 is equal to 8m plus 8 times k plus 9. So using this result, give its name by number 1 and give its name by number 2. So using number 2 result in number 1, we will get 3 raised to power 2k plus 4 minus 8 times k plus 1 minus 9 is equal to 8k plus 8m plus 9 into 3 square minus 8k minus 70. That is further 3 square means 9, 9 into 8k is 72k, 9 into 8m 72m, 9 into 9 is 81, minus 8k minus 70. So we get 72k minus 8k is 64k plus 72 times m plus 81 minus 17 is plus 64. So we get 8 as common and we will remain as 8k, 9m, 9 into 8 is 72 plus 8. So if we see that as k and m are natural numbers, this whole term is a natural number. So we replace it by m dash, where m dash is 8k plus 9m plus 8 belongs to natural numbers. So as we prove that p of k plus 1 is a multiple of 8, then we can say that this term is divisible by 8. Therefore, p of k plus 1 is q. So as p of k plus 1 is q, then by principle of mathematical induction, p of n is q for all n belong to n. So if we have such type of question, we have to prove that this term is divisible by some number. So we will proceed in this method. To understand this, we will do another problem. Now the next problem is problem number 8. Prove x raised to power 2n minus y raised to power 2n is divisible by x plus y. In problem 7, we have already done a divisible case problem. So, to improve this divisible case problem and to understand it very easily, to do more problem on the basis of that, I am going to solve this problem on the same way or the same method as we done in the problem number 7. So, the solution is let P of n is x raised to power 2n minus y raised to power 2n is divisible by x plus y. That is, x raised to power 2n minus y raised to power 2n should be the multiple of x plus y in some steps or in different cases. If we prove this, then the result will be true for that step. So in step 1, for n is equal to 1, P of 1 is x raised to power 2 minus y raised to power 2. By substituting n is equal to 1, we get x square minus y square. And the factor of x square minus y square according to be a square minus b square, that is x plus y into x minus y. So as we can see that P1 is the multiple of x plus y. Therefore, result is true for n is equal to 1. Therefore, P of 1 is true. Now we will proceed further in the step 2 for n is equal to k. Let us assume that result is true for n is equal to k. That is x raised to power 2k minus y raised to power 2k is divisible by x plus y. That is, by definition of divisibility, x raised to power 2k minus y raised to power 2k is the multiple of x plus y, where m is a natural number. So, P of k is true by our assumption. Now step 3, we have to prove the result for n is equal to k plus 1. That is, P of k plus 1 x raised to power 2 into k plus 1 minus y raised to power 2 into k plus 1 is divisible by x plus y. That we have to be proved. So we have to prove x raised to power 2k plus 2 minus y raised to power 2k plus 2 is a multiple of x plus y. So for proving this, we will take this part, that is x raised to power 2 times k plus 1 minus y raised to power 2 times k plus 1, which is equal to x raised to power 2k plus 2 minus y raised to power 2k plus 2. That is x raised to power 2k into further divided into x raised to power 2 minus y raised to power 2k plus 2. Give us equation as name 1. Now from step 2, we have x raised to power 2k minus y raised to power 2k is equal to m times x plus y. From here, we will find the value of x raised to power 2k, that is m times x plus y raised to power 2k, that is equation number 2. So using equation 2 in equation 1, we will get, that is x raised to power 2 times k plus 1 minus y raised to power 2 times k plus 1 is equal to x raised to power 2k is replaced by m times x plus y raised to power 2k into x square minus y raised to power 2k plus 2. That is, we have to multiply m into x square into x plus y raised to power 2k into x square minus y raised to power 2k plus 2. That is m into x square into x plus y raised to power 2k is common out and we will get x square minus y square. From the last term, y raised to power 2k can be written as y raised to power 2k into y square. So, further mx square into x plus y raised to power 2k, it is further factorized, that is x plus y into x minus y, that is a minus b into a plus b is equal to a square minus b square. So from here we get x plus y as common factor and in the bracket we will remain with mx square plus y raised to power 2k into x minus y. So we can see that p of k plus 1 is a multiple of x plus y. So p of k plus 1 is true. As a result is true for n is equal to k plus 1. So by principle of mathematical induction, Pn is true for all n belongs to n. So the result is true by principle of mathematical induction. So question of divisibility based can be done by this method.